Hello, I'm from the State Key Laboratory of Virtual Reality Technology and Systems at Beihang University. Today, I'm glad to present our work on adaptive skill alignment learning for continual perceptual quality assessment of VR videos. My presentation consists of 6 parts. First of all, let's talk about the background. VR videos are 360-degree videos that provide an immersive environment, allowing users to explore scenes in all the directions. VR video quality assessment, or VR'25, aims to evaluate the perceptual quality of these videos to ensure an optimal user experience. Without VR'25, distortions like blurring and stitching errors may cause discomfort and disrupt immersion. However, existing VR'25 methods suffer from significant challenges. First of all, current VR'25 methods are typically trained on small-scale datasets, limiting their generalization ability to real-world VR content. Secondly, they struggle to balance the precision and correlation. Both precision and correlation are crucial for ensuring an optimal user experience. The precision ensures measures how well our predictions match the ground truth, while the correlation measures the alignment of our human perceptions. Finally, thirdly, they fail to adapt to non-stationary variations, which means they variate user preferences and dynamic environment, etc. That this distribution will evolving, changing. Finally, VR devices have limited storage and computation capacity for the complicating efficient adaptation. In summary, we can merge these above challenges into 2 problems. The first one is limited distortion types hinder generalization ability, and this is also makes it more difficult to balance the correlation and precision. Secondly, non-stationary variation requires adaptation under resource constraints. Our core ideas to address these problems are twofold. Firstly, we incorporate reparameterization technique to our framework to improve both the generalization and the trade-off of precision and correlation. Secondly, we incorporate continual learning into our core framework to adapt to non-stationary variations. Continual learning aims to learn from new tasks while maintaining the old knowledge of previous tasks. The biggest significance of continual learning is catastrophic forgetting. That is to say, the model learns from new tasks and forgets old knowledge. In our problem, we further incorporate data compression technique to reduce the computation and storage overhead in VR devices. To this end, we propose the adaptive skill alignment learning ASO as an innovative solution to address these problems. It consists of 2 key phases. The first phase is memory bank construction. At the end of each task, we select representative samples, and we only store their key frames to the memory bank, which helps to reduce the storage overhead. The second phase is the continual learning. In this session, we learn from both the replayed data and the current session data. For the replayed data, we further propose an a feature adapter to reconstruct the whole sequence from representation space rather than from the raw data space, which have to reduce computation overhead. Finally, we utilize a reparameter regressor to regress the quality scores from both the replay data and current session data. We validate our proposed method on the VR'25 dataset. Currently, the biggest VR'25 dataset containing over 500 user-generated videos with diverse distortions. We further annotate this dataset into 6 classes to simulate the varied user preference. As can be seen in the figure, their data distributions are very different, which is very challenging to mitigate the catastrophic forgetting. Our joint training model result is shown in this slide. As can be seen in the table, Wind's method can achieve relatively high correlation, but suffers from larger precision errors. In contrast, our proposed method can achieve the state-of-the-art performance in both precision and correlation, indicating the effectiveness of our proposed method. Ablation study on joint training setting evaluates the core module's contribution of our proposed method. For the continual learning result, our proposed ASO method can amazingly achieve both the state-of-the-art performance in both precision and correlation, especially compared to recent strong baselines. And we can also observe a big gap between joint training and the sequential fine-tuning model. The fine-tuning sequential model is simply adapted from existing VR'25 method. This indicates that the catastrophic forgetting in existing VR'25 method for continual learning. Ablation study is here. We also conduct a flat minima test to further validate the generalization ability of our proposed ASO method. The comparison method is also our proposed method, which is published in ECCV 2024 and accepted as an oral representation. Amazingly, we can see from the results that our proposed ASO method can achieve wider minima, indicating the better generalization ability and stability. We also show some cases to have readers better understand the decision-making process of our proposed method. In conclusion, we propose ASO as an innovative solution to address the double challenges of precision, correlation, trade-off, and non-stationary variations. Our future work can consider 2 aspects. First of all, we can expand the dataset to include more distortions to further enhance the generalization ability of our proposed method. Secondly, we can also incorporate real-time user feedback into our framework to improve both the accuracy and efficiency of our proposed method. Last but not least, I want to leverage the remaining time to sell myself. I'm Kang Zhou. I will graduate in June, and I'm looking for a postdoc position after my graduation. My research interests focus on incorporating our human structure knowledge into the human motion analysis. Also, I'm open to other directions as well. So if you have a position for me, I can make it, and we can do better because I'm full of enthusiasm in research, and I'm really hardworking. Thank you for listening.
Thank you, speaker. Do we have any question from the audience? Yes, please.
Hello. Thank you for your presentation, and your English is very better than me, so you will get some jobs in English. So I want to ask you about this is very basic question because I'm not expert of this research. Why use such a test on your research? So there are several tests, and you showed me it's had very good results, but I want to know why you use so for please show me your some slides. Can I see your slide presentations? All right. So maybe explain after these slides presentations. These training. Why you measure by these trainings? Why you measure your data set by these trainings?
Why we use this data set?
Why you use such a test or?
Sorry to interrupt. Maybe we can discuss that after.
Okay. All right.
Because we are already late. Sorry about that. So thanks to all the presenters.